All right, so this lesson is on solving proportions. This is a prerequisite skill that you need to know how to do in order to do the next section in the book, or integrated, not in the book, but which is using proportions to solve. So we're just going to do a quick review on how to solve a proportion. So first off, proportion, how it physically looks, is two fractions set equal to each other with a variable in it somewhere that you have to solve for. So to solve a proportion, you cross multiply. So you're going to multiply these two things. 2 times x is 2x, and then put equals. Multiply these two things. 6 times 10 is 60, and then you solve that equation. Divide both sides by 2, and you get x equals 30. All right, number 2, same idea, cross multiply. 8 times k is 8k, equals 4 times 2, which is 8. And then to get k by itself, divide both sides by 8, and you get k as 1. So notice also I like to pre-look at it and see where the variable is, and I multiply those cross products first, but you don't have to. Okay, so right now you have a number 3 of fractions set equal to something that's not a fraction. So the first thing I'm going to do is make it a fraction. Now I can cross multiply. I'll multiply these two. I have 1 times n plus 5 is equal to 8 times 4, which is 32. If you distribute your 1, you still get n plus 5 equals 32. And then subtract 5 from both sides, and you get n is equal to 27. Okay, the very next one. Multiply these two. Whenever there's a binomial, I like to go through and put parentheses in it too. So I'll multiply these two. It's 8 times k plus 6 is equal to, multiply these two, 9 times 6 is 54. Now there's two ways of solving this. You can distribute the 8, or you can divide both sides by 8. I think most students will end up distributing the 8, so that's what I'm going to do. That's 8k plus 48 is equal to 54. Subtract 48 from both sides. That's 8k is equal to 6, and then divide both sides by 8. So I have k is equal to, we can write this as a simplified fraction. Both of those numbers are even. So 2 goes in here 3 times, 2 goes in here 4 times, so k is 3/4. Okay. Next one, I see a binomial, meaning two terms separated by subtraction or addition. So I'm going to put it in parentheses, and then I'll multiply those two. 2 times a minus 3 is equal to 4 times 10, which is 40. Distribute your 2, that's 2a minus 6 equals 40. Add 6 to both sides. That's 2a is equal to 46, and then divide both sides by 2. A is equal to 23. You could also always check your answers by plugging it back in and seeing if it's true. If I plug in 23 for A right here, I get 4/20, which simplifies to 1/5, and so does 2/10. 2/10 also simplifies to 1/5, so it is true. Okay, next one. I see a binomial right here. I see two different m's, so it doesn't matter which one I cross multiply first. I'm going to do this. 8 times m plus 7 is equal to, multiply these two, 8m. On the left side, I need to distribute, so that's 8m plus 56 is equal to 9m. And now I need to solve m for m. There are m's on both sides, but 9 is more, so I'm going to leave it, and I'll subtract this 8m from both sides, also because otherwise if I subtract 9m, I'll have to put equals 0 over there. 56 equals m, and that's it. Okay, the next one. I see a binomial, so I'm going to put it in parentheses. Multiply. 7 times x plus 6 is equal to 10x. 7x plus 42 equals 10x. I'm going to subtract 7x from both sides. 42 is equal to 3x, and then divide by 3. And I get x is 14. Here, I see an r minus 10, so I'm going to put it in parentheses and multiply those two first. 4 times r minus 10 is equal to 9r. Distribute your 4. 4r minus 40 is equal to 9r. Subtract 4r from both sides. Negative 40 is equal to 5r. And then divide both sides by 5, and we get r is negative 8. All right, so last two, I see an x plus 4, so I'll put that in parentheses, and this x plus 1 in parentheses because there's two binomials. I'll multiply those first. I have x plus 4 times x plus 1 equals 4 times 10 is 40. All right, now I need to solve this. So a thing that some people do wrong is they try using the zero product property here. They try setting this equal to 40 and this equal to 40. You can only do that if it's equal to 0 because you're using the zero product property. So that's not going to work. So what you can do is you can multiply these two binomials right here. So we can expand this to make it a quadratic. Distribute x times x, or first is x squared. Outer is 1x. Inner is 4x. Last is 4 equals 40. So now I have x squared plus 5x plus 4 equals 40. Now if you look at this, this is a quadratic and it looks like I'm ready to solve it. So the first thing I ask myself is, can I solve by square rooting? There's an x squared and an x, so no. So now I'm going to try to solve by factoring. Remember, to try to solve by factoring, it has to be equal to 0. So I do have to subtract 40 from both sides. So now I have, I'm just going to write it over here since there's plenty of room over here, x squared plus 5x. And then I have a 4 minus 40, which is minus 36, equals 0. So now I can try to factor it since it's equal to 0. If I can't factor it, then I move on to quadratic formula. Look for GCF. There's nothing in common. So I'm going to use my organizational x here and hopefully come up with my two factors. A times c is negative 36 and b is 5. So I need two numbers that when I multiply them I get 36 and I add them I get 5. 9 times negative 4 is negative 36 and 9 plus negative 4 is 5. Divide by a. So I have x plus 9 times x minus 4 equals 0. So I have two solutions. X equals negative 9 and x equals positive 4. All right, last one's super similar. Go ahead and pause the video and try it on your own and check back and see how you did. If you got x equals negative 7 and x equals 5, you're good. You can move on to the next set of notes. If you didn't, let's see what happened. Both of these are binomials. I'm going to multiply them first. So I have x plus 6 times x minus 4 equals 1 times 11 is 11. I'm going to FOIL the left side, or just use the distributive property. It's the same thing. X squared, outer is negative 4x, inner is 6x, last is minus 24 equals 11. I have x squared plus 2x minus 24 equals 11. Once again, can't solve by square rooting. I'm going to try to factor it, but it needs to be equal to 0 in order to do that. So I'm going to subtract 11 from both sides. I now have x squared plus 2x minus 35 equals 0. All right, still can't solve by square rooting. Looking for a GCF, there isn't one. So now I'm going to use my organizational x to see if I can factor it. A is 1, B is 2, C is negative 35. A times C is negative 35, and B is 2. I'm looking for two numbers that when I multiply them I get negative 35, and when I add them I get 2. 7 and negative 5 will do that. Divide both sides by A, and I have x plus 7 times x minus 5 equals 0, so I get two solutions. X equals negative 7, and x equals 5. All right, well, that's it for solving proportions. Now we'll actually put these into some geometry problems, and this will be the algebra you have to do in order